community. I did my honors degree in running a HCM3, and then when I finished my honors, I got an opportunity to go study for a master's degree at the University of Cape Town on climate modeling, and that's what I did. I moved there to study climate modeling for my master's and my PhD, and end up staying there for a 5-year postdoc, and then moved to working for the Red Cross to try to interpret information from climate modeling to manage risks in many countries in Southern Africa. And then in 2022, last year, I moved to the Netherlands, and that's where I am currently. Thank you.
Okay. Well, good afternoon, good day to everyone. I'm sorry, but I have 4 decades to tell my story, so I will try to be brave. My journey started in the 80s, late 80s. So by those days, as a scientist from Argentina, we did not have climate modelers at all in our community. So that's where I started. And there were no climate model simulations available in Argentina. We were not able to run that kind of models. Instead, we could run some simplified models to address some issues, paratropic or that kind of models. Then Professor Orlansky from the GFDL, US, Geophysical Fluid Dynamics Laboratory in US, came to Argentina. He stayed in Argentina for 5 years at least, and he started a very interesting group there. I was part of that group, and he also brought 3 models with him, one global, one for the ocean, and one which was a limited area model. And that is what the one I liked more. I liked the regional modeling, numerical weather prediction in those days. So I started, thanks to Isidoro that came to Argentina, stayed in Argentina, and brought his model, because models were not opened at all by those days. Then between the 90s and 2000, I would say that we saw an interesting development in Brazil. My colleague Paolo, who is here, they had the infrastructure to run global models, so we had nice collaboration. So I went to Brazil to do something with our colleagues there. Still, I preferred the numerical weather prediction area, which was connected with the ETA model by those days. And then here, for me, the key aspect is bringing infrastructure and knowledge and models. Then between 2000 and 2010, I would highlight the increased open access and inclusive ways of sharing information, which was facilitated by the WCRP, the WCCP, and other international efforts. And particularly, I would like to highlight the WRF model as a key instrument, open source, to bring us to the modeling arena. And so, well, I will stop there, and I will try to follow the time schedule and many other things to tell to the audience afterwards. Thank you very much.
Thank you very much. I think it's very difficult to follow on your footsteps. So for me, I'm a climate scientist based at IGAT Climate Prediction and Application Center. I was born in Zimbabwe. So I started off as studying applied mathematics. So that is what I focused on. And in my career journey, I have really received a lot of support from family and then from also a lot of mentors within the university. So after finishing my applied mathematics degree, I was offered a scholarship to do industrial mathematics. So after finishing my industrial mathematics studies, one thing that I captured my mindset was the issue of the butterfly effect. So I felt like, oh, that is a very interesting concept, and it was in the chaos theory class. After my master's, I then went on to work as a lecturer. And then during this time, I was kind of living very close to the village. And I realized something like, in terms of planning and decision making, it was really difficult for most people. They were not making decisions based on what was being offered. So in my mind, I was like, I think I could really use my mathematics degree to inform decision making. So that is when I applied for a scholarship, and I was able to do a PhD in climate science. So during my PhD in climate science, I was mostly focusing on running the weather research and forecasting model. So that I was doing over Eastern Africa. And that is the reason why my focus has continued to be over Eastern Africa. And then during that, I also utilized the regional climate model, the REGCM. So basically, that is my journey for my career.
Thank you. Well, thank you, Paolo Nobre. I would say that how did I get here? How did I arrived here? And my whole story is the fruit of international collaboration. And in one line, it is Brazil, where I was born, the United States, and India. And I will show how it happened. I started my undergraduate at meteorology at the University of São Paulo in 1970s, something, and eventually end up to National Institute for Space Research to do my master in meteorology. And as soon as I finished it, I got a United Nations fellowship or scholarship to come to University of Maryland, where I met my future advisor, Professor Shukla. There, I eventually came back and did my PhD at the University of Maryland, and eventually my postdoc at Columbia University with Steve Zibiak. And so how did I come to modeling? First, it was COLA, Center for Ocean, Land, Atmosphere Laboratory in the University of Maryland, that made the atmospheric GCM available to Brazil. And GFDL made MOM, at time MOM2, eventually MOM3 available. And I was given this task when I came back from my postdoc to create the Brazilian coupled model, global coupled model, that eventually became the Brazilian Earth System Model, BESM, which we participated on CMIP, etc. And so I have my gratitude for all the institutions that allowed me to come from Brazil. I had no idea I would end up being a scientist in meteorology when I was a teenager. I taught in engineering. But because of this support and the trust that we could receive by being able to start working with these developments, both at COLA and GFDL, and I name here in GFDL, is the personal links. Balaji, that is one of the developers of the MOM, that also gave us a lot of help in several portions. Where we are now today we are Brazil, myself and Ayantika in Indian Institute of Tropical Meteorology and Professor Zhang and the Institute of Atmospheric Physics in China. We were contemplated with a program to keep developing this jointly, internationally, the BRICS joint program. So in a short, this is how I got here.
Hi, I'm Adrian Tompkins. So my journey kind of started actually after the bachelor. I worked for the government for a few years actually, so my PhD was quite late. It was at Reading University. I've been really lucky because I've had a really wide experience in my opportunity to have a wide experience in terms of I then moved to Max Planck, where I could work on climate model development with Eric Röckner. I then had the opportunity to move back to the UK and work in ESMWF in the research department. And there, it really was a very different experience, superb computing resources, and also the first opportunity to really link directly with end users, all based in Europe. I saw Francesco came in at the back. He's the director of the Barcelona Supercomputing Center, but he was a colleague of mine at the time. And I recall that there were the envelope of products was far larger than what was actually being used, even within Europe. Nobody was using very much the EPS system at the time. And so then I moved on to ICTP 16 years ago, in fact. And there I've branched out a little bit. So as well as working on climate dynamics in the tropics and feedbacks, I've also expanded into climate and health. And I moved there partly, the motivation was the opportunity for outreach and training across the globe. So I've had the opportunity to be involved in, or actually run, direct, teach at more than 40, 45 schools, of which on the order of 25 have been outside of ICTP. And I've actually run more than 15 here in Africa. And so as part of that, it's really been trying to, we're going to talk probably in this session about the cloud resources, high resolution, the cloud infrastructure, the development there. But a lot of these schools have also really been trying to focus on the basics of, we're in a global data revolution in terms of open access with Copernicus in Europe. And so a lot of these schools have been based around trying to teach what products there are, how to access them, and actually take advantage of what's actually out there at the moment. And so a lot of the most successful components of the school have been based around trying to take advantage of this new kind of open access revolution. So that's kind of my, should we say, pitch where I am at the moment. And so I've had this operational and climate kind of experience. So I'm looking forward to the session.
Wonderful. Thank you for sharing your stories. Really diverse kind of journeys, but also some similar themes coming through in terms of, how changes in access to infrastructure have come along the way, and access to community models and international collaboration. Okay, so I guess, we have a few questions to the panel, and anyone is welcome to answer them. So the first question is change happening? So what changes have you seen over the past decade in terms of these barriers to climate modelling and being a more inclusive climate modelling community? Anyone want to start?
Well, when I first went to the US in 1985, I had to bring one magnetic tape with the data in order to be able to analyze and run the first toy models. Today, in this, we have enormous access in Brazil for supercomputing and worldwide for data. Say, today we have this, we just saw here, carbon and currents, temperature, global, in real time. And the Pirata array in the Atlantic, for instance, is one thing that you download at your home. So during this last 10 years, the amount of opportunities that the new generations have is enormous. So this, I would say, this is the most impressive changes, that if one student wants to get there, the data is available, the models are available, and the organizations, then we will talk maybe in another point, the organizations that will harvest and invite students to use this wealth of information and tools to understand and predict the climate system.
Okay. So I really agree that there's been a lot of change. Even when we look over our region, we can see that there are quite a number of institutions now that have access to high performance infrastructure. So at least this can enable modeling to improve. But I feel like there are still gaps that are available. So if we look at Sub-Saharan Africa in terms of the data that is available that we can actually use to improve the model parameterization, we still have quite a lot of gaps. So it makes it really difficult to improve the models. And then also in terms of parameterization. But really, I think we have kind of come a long way now. We are talking of even cloud computing, having access to that, collaborations with quite a number of institutions that have the infrastructure. So for example, within ICPAC, we do collaborate with a number of UK institutions or European institutions. So within one project, we were given access to the Jasmine supercomputing system. And then now we also have access to the Norwegian supercomputing system. And we are actually using that to produce some of our forecasts and downscaling. So in terms of that, yes, we agree. There has been a lot of improvement in the past decade. Yeah.
Thank you very much. Indeed, I agree with both of them in terms of how things have been moving forward. Still, I think that I agree also particularly with you that there are several gaps. And also, I would like to mention something that I wrote here that was very critical in the 19th and 2000s, which is a hard distinction between the modelers, which were VIP persons, and those that were using the models, that were common people, I would say. I think that we as a community should also work on those barriers. I think we there have something to really work, because of the infrastructure, sometimes you cannot become a modeler, and still you can add value to what the modelers are doing. And this is something that we are not there yet. The modelers are working in their systems, and sometimes they give access to their systems, but there is no feedback from the outside world into the modelers arena. And that is something I would like to be differently in the near future. Thank you very much.
I can just quickly add that in the past 10 years, we have seen also the type of models that are available. Before we would need a supercomputer to run climate models, but nowadays we can use simple climate models that are able to run on our personal computers, and that is really good for teaching as well, which helps a lot. And also we have seen the availability of tools to analyze climate data, that a lot of people have access to that in the past they did not have.
Just super quick. I mean, if I look at in the context of ICTP, the change there has really been on the kind of services. When it was kind of first formed, 40, 50 years ago, it really was just a place to access a library, come and work, maybe have access to a small computer. The range of services that we now have to offer has grown considerably. But I have to add at the same time, one of the things that hasn't changed is the kind of permanent fixed funding support for these kind of outreach and training. I mean, for example, ICTP doesn't have €1 more of funding since when I actually moved there 16 years ago, not a single euro. So in real terms, it's been a huge cut. And yet the services we have to provide have massively spread. The other institutes that are similar to ours, IRI, they do fantastic things, and we can see the situation there. So although there are many more opportunities, should we say training and education, a lot of these are project-based and they don't have a long-term, should we say permanent footing, such as institutes like ICTP can offer. And so I think that's one area where change hasn't occurred and perhaps should have done.
Okay, thank you. Yeah, I guess that leads on nicely then to the next question is, what can those in more well-resourced organizations do to drive progress in terms of, both opportunities for collaboration, but also funding to help with these? And I guess, Celeste, you talked about, and I think Masilin too, about actually feeding back into model development is still a real barrier.
Maybe I'll just
got the mic.
So, just super quickly, I mean, I think in terms of the high-end performance computing, I think this is where some of the new endeavors, such as the proposal for Eve, is really quite exciting, because that will be something that people talk about Eve as being global CRM, and it might actually increase disparities. I actually think it's super exciting because it offers computing infrastructure which is equitable and should be equally accessible. Whereas at the moment we have a situation where these large infrastructure centers are based in the US, they're based in Europe, and there's really a massive barrier to their access. There was a talk right before the break, actually, in our session there, saying exactly that the barrier actually exists on getting used to running and using these cloud infrastructures. So I think opportunities such as EVE will really start to level the playing field.
If I may continue on your topic, two things I think the can be done. One is that to realize that we need a massive amount of brain power, innovation, that is to make it possible that the modeling community in the Global South can run their experiments in these massive supercomputers will be one paradigmatic change. The other one is to invite kids. You know, modelers have been kids one day, and seeding the wish to become one scientist is in desperate need. So what can be done is there is so much money in the supercomputing or our ability to measure the oceans and the atmosphere is to have a sustained program to invite kids to go. Kids, I mean, all ages, different programs, but has to be continued that we invite kids to travel abroad. So the Science Without Borders program, in which we could have different programs for different ages that we will seed in the kids, today's kids, who hasn't been a kid, the wish to become a scientist or etc. So I would just leave these two open gates for the well-resourced nations to open, and that we can work in this lateral connection, the mobility of scientists and scientists to be.
So I really agree with that. One of the most important things is capacity building. I think with capacity building, we can even see like Sub-Saharan Africa also coming up with their own regional climate models. Because when you look at this point, most of the models that we're using, they are built in the developed countries. But if you start from a young age, like what you are saying, then after some time, we'll have that capacity to actually be able to develop our own models that might be like represent the systems that are okay of our region better.
Thank you. I think that progressing from what we've been listening from my left to me, I would really love to see if we can summarize what has happened. I speak from my history, you know, from young people moving to the developed world to learn, to study, to get their PhD, their postdocs, and so on, and then back home. It's a way of building capacity, but it is not enough. I would love to see the other way around. So scientists from the global north moving to the global south to do their research with us to see which are the limitations we have in our countries. So in that way, and that is what I call co-production, in the sense that you can only co-produce if you understand the environment. Otherwise, you try to replicate your own environment in a different place. Of course, nowadays that you don't need to travel exactly, but you need to engage. I would like to change the word. Instead of speaking about traveling or staying in the global south, at least engage and work with the tools that are available and in the way they are available in the global south. That would make a difference because we will change the flow of science from south, which was usually from south to north, and then change it from north to south. And then it will be more, I would say, inclusive and I would say fair in a way. Thank you very much.
No, Paolo suggested the program for youngsters. He referred to like possibly calling it Science Without Borders. We actually have a program, Science Without Frontiers, it's called at ICTP. It's kind of a roadshow, especially led by postdocs. They go to a country and they do a series of roadshows, stopping at basically schools and doing exactly this. It's funding and time limited, unfortunately. It could be scaled up so much more effectively if we could afford to actually have the support. So the number of these roadshows that we've been able to do has been very small in number, and it's because it's resource limited. It's a pity, and it's a fantastic idea that Paolo suggested.
Fantastic. Thank you. That was all really informative and lots of ideas for how do we, keep the change going. So the final question is, what helped you get to where you are, and what advice would you give others, I guess, now to get into the climate modeling and to keep breaking those barriers down?
For me, what helped was mostly institutional support. So the supervisors and my colleagues, they helped me and they supported me on all the choices I made. So institutional support is really important for career development.
Okay, yes, I wrote mentors, institutional kind of support or programs, definitely. Data infrastructure sharing with open source codes and so on. And the last one is moving out from your comfort zone. Otherwise, nothing will change. Thank you.
So for me, what got me to where I am is mostly family and then mentors. So really, for example, for me to get into my master's program, it was the chairperson of the department who actually called me when I was actually coming from church, and he asked me, do you want to pursue a master's? And I said yes, and then I got there. And for my PhD, I was also told by the department chair, and who said, there's this Fulbright fellowship, would you like to apply for it? And I took it. So mostly the family, mentors, and then also institutional support, yes.
Well, I would say time travel. Time travel, what was brought me here. When in 1985, I transferred by FTP 100 megabytes from NASA to College Park. That was wonderful. And so I saw that it had to be the way I was used to live in my country, in my place. So if we can provide this ability that we can see beyond the difficulties of today, and invite our researchers, and then this comes back to the mobility, that see that there are other realities. Our local reality is not the only reality that exists. So there are other ways of doing it, not right or wrong, but other ways. And we have a place in the world. Said, I would just leave these recommendations for the ones that are still going to go through this, your lives, is there is a place in the world that's waiting for you. Discovering it, it's your task. Promoting it is our task.
Mine is really as a tangent. I would say just make sure that your research stays curiosity driven. I think actually that one of the scary things, which I think might actually become an impediment, is this drive towards index-based assessment and chasing citations. I had a scary experience just very recently, in fact, because I'm on I have to be assessed because I can supervise PhDs at the University of Trieste. And they recently came back when they had a department assessment and told me, could I remove a paper that I had submitted as one of my 5, because it was a first author paper in the Journal of Atmospheric Sciences. And apparently the Journal of Atmospheric Sciences is now second quartile. And I found that quite shocking, actually. So it means, you know, the way we're moving in the, should we say, in the field towards this index-based, H-index-based, citation-driven kind of assessment of scientists, I think is really scary, actually. And it's very worrying.
Fantastic. Thank you, everyone. So we're now going to open it up to questions from the floor or online. So if you have a question, just come up to the microphone. Yeah, go ahead. Hold it on.
There we go. Okay. Yeah, it's working. All right. So I have a couple of different questions, but I guess I'll start with this one. And it picks up on something that Celeste and Masilin said, where Celeste mentioned that there's this gap between climate model developers in the community and users, which might create certain inconsistencies in terms of development decisions, what is prioritized, and what the users actually need. And then Masilin said something about how there was this additional value in being able to develop your own regional model because it's much better fit for your purposes in your context. And so I'm curious, with some of the kind of current modeling endeavors that have been, I guess, introduced, so thinking specifically here about Eve, which is meant to be this, in my understanding, super high resolution 3-kilometer global model. I'm curious how you're bringing in people from the global south that are either users or capable of development, so that their priorities are represented in development decisions, so you can get that kind of downstream fitness for purpose, or at least adequacy for purpose in that model for the global community. And I'm additionally curious about how, if when bringing in these additional communities, if there are conflicts between what the priorities are in terms of what the model needs to do, how you're going to adjudicate between those conflicting perspectives and priorities.
Okay, does anyone want to attack that? Yeah.
So thank you very much for that question. I will tackle part of that question. Possibly you would like to add on top of that. I think that Eve is an incredible initiative, but as such is, again, building centers of excellence that probably will not be in the Global South, for sure.
Can you maybe explain a bit what Eve is for the audience?
Okay, for the audience. This is an initiative that will be discussed during this week. It started as a new initiative to have a kilometer scale kind of climate modeling to also build projections and also to address the local problems of the stakeholders who may need much more resolution, and possibly, Adrian, you are much more that then you can complement this. But going back to how Eve is being discussed, I would like to see if we could because it does not only speak about modeling, it also speak about information, sharing of information, and sharing platforms that would allow all of the world to get the best of the model. Still, I think that we have to be very sure that we prioritize, not again the same kind of developing better models, because this will not be an inclusive approach. I'm not sure. We will need to see. We will need to build it from generating more information for decision making, starting from there, showing that it has value. It has value for the decision makings for all over the world, and then build from that because it mentions about 4 or 5 centers of excellence, possibly. So we could share those priorities in some meaningful way. Thank you.
So maybe I can just super quickly follow up on some of the Eve details. Yes, so I mean, you're completely right that it's unlikely that a hub will be based, for example, in Africa in the first phase. The idea is to have regional hubs. So I think in the first instance, there would be perhaps one in Europe and one somewhere based in the Middle East. But what's crucial to emphasize is right from the outset, the accessibility is emphasized right in the design of the project, such that at least 20% of the resources will be available to support training and mobility into the institute. So the idea is then that, for example, institutes such as ICDP would be able to offer like their diploma programs they already have, where we already support people to come from countries all over the world and do a one-year intensive course like a master's, that we would then be able to, with the support, actually massively expand that and have a very strong HPC component to that, so people could rotate in, learn how to use the systems and so on, so that then they, when moved on to one of the hubs to do their science and interact with the scientists in both the model development and also the applications models that would be linked inside that infrastructure, that they would be in a position to do so. They would be able to rotate in and out. So the idea is that it would actually try and break down those barriers that we have at the moment, where we have the HPC infrastructure, for example, based in Europe, and it's very difficult to access it without strong IT support. So I think that should be emphasized, that emphasis that we have in Eve on that mobility and training.
Can I make a comment? I would like to make a comment on, first, we must be aware that models are not oracles. They are built from the partial knowledge we have about processing nature. So convection, for instance, etc. So how a raindrop forms. So I think the first thing is that we must improve the models in how they represent the physical basis. And yesterday evening, we had in this room here a show of new developments made in terms of parameterizations, etc. So knowing that we must not be model runners, but we must be people capable of represent mathematically what nature does. And I will give you one example. In the Amazon, we had plenty of talks about Amazon tipping point, tipping deforestation, etc. But up until recently, we didn't know how rainfall formed over the Amazon because it's so clean air. So how did the raindrop form? Eventually, we learned about the VOCs, the smell of the trees that are hygroscopic. And then comes the thing that the indigenous people in the Amazon already knew it, that the trees talk to the clouds and make it rain. How do we incorporate this local knowledge into our GCMs? So there is a gap, and we must address this, that local knowledge must be incorporated. And knowledge is the treasure that we have in terms of predicting climate change. We cannot afford to throw away knowledge because it is written in a language that I cannot recognize. So I think there is an enormous possibility for the whole globe of indigenous people to talk. And this is hard because we don't understand how the local gatherings, people in Africa, South America, in Europe, etc., transmit knowledge. So I would defragment the question of modeling to a most fundamental need to express mathematically what a model is, a mathematical expression what nature does.
Fantastic, thank you. And remind people that we have this Slido, so you can scan the QR code there and add your questions through that if you'd like. But we do have one question from Slido. So one view we can take on climate model is as a software systems, better documentation of codes used can be helpful in inclusion. Are there any examples or efforts on this? So about, I guess, better model documentation as a way to address barriers.
Sure. Documenting? Yeah. I think I'm sure. So, okay, you can go ahead.
Let give one example. When I did my PhD at the University of Maryland, Brian Doty developed a software called GRADS. Many atmospheric researchers do use it. It's a way that you can open a data set and do a plot in a few seconds. So this kind of tool set, and then imagine you can go right now to NOAA PMEL site and download 25 years of ocean data and plot it and compute the trend and say, hey, there's something here. So the ability to instantly develop idea with your group after hours is one way that is a nonlinear creativity. If the software to do that analysis is so hard that you go home the next day, then the magic is dissolved, because the magic happens when it happens. It's a highly nonlinear process that you have a group of people with proper software, and you see, GRADS is a visualization tool, but it allows you with effortlessly to mass and compute the divergence of the flux, et cetera, et cetera. And so that's what I would say. There are a number of softwares already today that allow us to mass data and model results and go for this creativity in which age or experience, they all add up. So this is a crucial thing for us to do.
And I know many of the community models, like people have mentioned WRF and MOM and CSM, are open access or downloadable and documented. And we do in CMIP have a model documentation task team who are really trying to kind of improve model documentation as well.
Yeah. So I wanted to add on to what you have said, like there's really a lot of documentation. Like you have said, if you go for the weather research and forecasting model, it gives all the steps in terms of how do you even compile and how do you run some test cases. And then also nowadays, there's also GitHub. You'll find a lot of documentation in terms of a lot of things. So even now at ICPAC, we have developed like CIVAL, an evaluation tool. All that information you can download from the GitHub and be able to do analysis. Yeah.
And I would just add the example again of Copernicus I mentioned at the beginning. I mean, it's really revolutionizing a kind of one-stop shop, well-documented access to reanalysis, observations, climate applications data, and also, of course, you can even access the CMIP data there. It's all well-documented. It really is, I think, a revolution in open data access to both climate models and also operational forecast model output, such as seasonal forecasts.
Yeah, I think there's still a lot of work to do in terms of making it usable for the general person to access or to use. So we are running out of time. And so there are some questions still remaining on Slido. And just to let you know that we'll put it on the CMIP website, FAQ, and with answers provided there. And so I guess to finish, we just wanted to get, I guess, a short statement from each member of the panel on what they think the main takeaways are from this session in terms of, addressing barriers. We've had a lot of, I think, good progress that is made, but there's still a lot of work to be done in, I guess, these visions of what it could be in actually making them happen. Yeah.
So for me, I think we need to be more innovative and then take advantage of all the advances that have been happening. Now we have cloud computing, we have new technology coming up, new techniques like machine learning. So we need to take advantage of all this and become more innovative, and then also have techniques that can easily collect data so that we improve our models.
I think one takeaway for me is that we need a community of practice, of curious people, and also it's important to have fun.
Great. Having fun is very important. Definitely. I would add also, continue this open access revolution that was mentioned before. and also the way in which we evaluate the results of our research in terms of it's not only about publishing papers, it's also about engaging with the community and the society. And that sometimes does not bring a paper as soon as we need it, but we need a community of researchers that really see the value in doing something different. So I would like to highlight that.
Yeah, I would say that we are not alone. That's my message. You are not alone, I am not alone. That we as a community, we can do things that are unthinkable. So realizing that we are not alone, that there are giants up there. And who was this that said, whatever I said, because I was on the shoulders of giants, Newton and Einstein and others, there are giants there and we can ride. The giants are willing to give us a ride with our ideas. So I would say that we must find where is my place in this community that I can help with.
Yeah, well, I just wanted to emphasize the point I made about staying curiosity driven and then having fun. But I also feel that we really need to, when we move towards these high-end computing infrastructures and so on, we really do need to recall that we need to have a wide spectrum of training and open access. It's like you were saying, it starts right from the very simple things right through to the very high-end HPC support. So, I mean, some of the things I find are most appreciated are just simple online videos of how to use CDO and so on. So you really have to cover the whole spectrum and not just focus on the most complicated questions.
Fantastic. Thank you, everyone on the panel. Can we please give our panel a round of applause? So I think they've, really articulated well how we're aspiring to be a real, truly global community in terms of climate modelling and continue to try and break down some of these barriers, and I think giving us some good challenges as someone from the global north to engage in more diverse ways, not just hosting visitors, but also going to visit those places. So thank you very much. We have some other events that are running this week, so please come talk to the WCRP booth where we have the CMIP IPO, and thank you to the CMIP IPO for organising this event as well. Thanks, everyone.